All right, see you.
I forgot.
Hello, everyone. My name is Kron-Piatek. I am the academic technologist here for the Center for Online Learning and Innovation at Canisius College. My colleague Mark will be also presenting. I'll let him introduce himself when he gets up here. But we're just going to do a very quick introduction to 3D printing today. This isn't. Some of you, as I think I heard a few people talking about Stratasys, some of you are definitely professionals. I would call myself a hobbyist, so I'm still in the beginner stages of 3D printing. So I'm kind of hoping that this helps other people also get into the beginner stages of 3D printing. So 3D printing, let me actually do a slideshow really quick, just so that's bigger. 3D printing is basically just converting a 3D digital model, or in some cases a 2D SVG, excuse me, into a physical model that you can hold. There's a couple of different forms of 3D printing. The two main consumer-ready forms of 3D printing are FDM, which is fused deposition modeling, which is what we have right here, and SLA, or resin printing, which is what Mark is going to be talking about. And they're all part of additive manufacturing. What that means is essentially that all it does is it adds to the product that you are creating. It doesn't take away any materials like regular manufacturing can. There's a bunch of different uses. I've got a list here, and I've also got a house, a very artsy house, one of the first 3D printed houses called the Tekla right here. But it's used a lot in research and for fast prototyping. Dremel Tools actually used and had their own 3D printer at one point, where they just made handles and tools and a bunch of other stuff out of FDM prints. There's also prosthetics and other medical devices. Recently, Prusa, which we're using a Prusa Mini right here, Prusa actually made a call out to all makers, which is basically just their printing community, to create slings and other medical devices for the war in Ukraine. But it's also used in for other medical devices as well as prosthetics. But anyway, so we'll get past that really quick. I've got just this really quick slide of an FDM printer, or the parts of the FDM printer. Yeah. But suffice to say that there is something that heats the material, which is called filament, which is basically just a long string of plastic, and then that heated filament gets turned into layers, which then creates your 3D object. The basic process is you create your or find on a 3D sharing website like Thingiverse, or Cult 3D I think is one, and My Mini Factory. You create it, you export it as an STL file, convert it into G-code using a slicer, which translates it into something that the printer can understand. And that slicer information has everything from how hot the print head should get to the type of filament being used, as well as where the print head needs to be at a given time. And then you just print it. It sounds a lot easier than it is, and I've got another slide for that in just a second. There's a bunch of different programs that can be used. Basically any 3D object or 3D software that can export an STL or an OBJ. STL is preferred because it's got, the slicer can better translate the data from the STL over the OBJ. But you can use any computer-aided design or CAD software. We will be using Tinkercad, which is a free software that is online and automatically saves. Which is kind of a gateway to, I think, Fusion 360, if I'm not mistaken, or AutoCAD, one of the two. But you can also use Autodesk Maya, Blender, a bunch of other things. You can also use phone apps. There are 3D modeling phone apps that you can use as well. Yeah. So, this slide. I just added in like literally 5 minutes ago. You don't need to be a wizard to do 3D printing. Like I said, you don't even have to model anything. You can go to Thingiverse, excuse me, My Mini Factory, or some other place, or even Fiverr, and ask someone to create a 3D model for you, and just get started. It's relatively cheap to get into 3D printing. Most printers cost anywhere, most beginner printers cost anywhere from like $300 to $500. But that's like an upfront cost. You don't have to necessarily pay that again unless you want to get another printer, which might be useful sometimes. But the filament is relatively cheap. It's like $20 to $50 per reel of 1 kilogram filament. And it also depends on the type of filament that you're getting and from the manufacturer. But it doesn't take a lot to get into 3D printing, is essentially what I'm trying to say with this slide. So we're just going to get started with Tinkercad. It's free, it's easy to use, easy to access, and because it's an online program, it auto-saves, which is really great sometimes, especially when you've spent 3-4 hours on something and then all of a sudden your computer decides that it doesn't want to work anymore. And you forgot to save during that entire time. Alrighty. So, I'm just going to show off a couple of my designs that I have created. The first one is, it's a really simple version of Our Lady of Victory Basilica in Buffalo here. Obviously some of the dimensions are not correct, and I actually have a picture of it right here. Some of the dimensions of the model that I created are definitely not correct. It's also got a few other issues with it, like right here, that would be taken care of by a much more robust 3D modeling software. But Tinkercad is just really great because it's simple, is basically how that goes. I also created our Center for Online Learning and Innovation logo on a plinth. I have not printed this off yet, so I'm not entirely sure how this is going to work, but we'll see. So, when you first get started with Tinkercad, like I said, it's free. You just need to create an account with Autodesk. When you first get started, it will take you through like a 20 to 30 minute introduction of Tinkercad. It's also got these lessons right here that you can go and get deeper into Tinkercad. This code blocks thing is something that I've started learning myself, which kind of gets you started with coding as well as 3D modeling, which is interesting. But anyway, so I'm just going to click on Create New Design. And here is your workspace. You can zoom in and out, select things, rotate. You can edit the grid. Right now it's set to millimeters, but you can edit it so that it is in inches or their bricks. I keep it in millimeters. Most every 3D printer is in millimeters. If you find that you're having a hard time and your computer is just being really slow, or your browser rather is being really slow, you can reduce it, the graphical stress that's on your browser or computer by just turning off the shadows right here. So yeah, I'm just going to hit cancel right here. You can change the snap grid so that you can be as very detailed, I guess, with the snapping as you want. But so let's get started with bringing a couple of things in. On the right here, you have a huge library of basic shapes, as well as other shapes that people have created in Tinkercad and have shared. So, but we'll stick with the basic shapes for right now. All you do is you just click on a shape that you want and drag it in to the work plane. On the right here, you have some of the things that you can change about the shape as soon as you get into it. Like, for example, the radius will make it a little bit more curved, if I can grab that correctly. There we go. You can even turn it into a sphere if you turn the radius up a little bit too much. You can change the length of it. I will go 50. I'll keep the height at 20. With that said too, Tinkercad is very, I'm going to say widget based, which is both good and bad. But as you can see, if I hover over one of these widgets, a number pops up. I can click on that, and then I can click on this number and change the length of the object. And then the same thing here. like I said, it's both good and bad. It's great because there's less information overload hitting you in the face, but sometimes you kind of want that stuff just to make sure that you are doing things correctly. To rotate an object, you've got these rotate widgets right here, and it's also based on the orientation of your camera. So these widgets will change and move with your camera as well, which is kind of hard to understand sometimes. So I'm just going to click on this, pull that up, 200 with that. Might be a little bit too high. So I'm just going to pull that back down. Maybe we'll go with 50 instead. I'm just going to create a really quick table right here, but if anyone has any questions right now, just let me know.
I have one.
Uh-huh.
With the tendency that I think a lot of people are seeing, they're trying to move away from plastics.
Yeah.
Where does 3D printing come in? Are they going to develop a new material to be a replacement or an alternative for the resin that is used?
I'm going to let Mark speak about the resin, but with FDM printing specifically, you can, that has been talked about a lot in the 3D printing world, where they have, there are companies that actually have created recyclers, I'm going to call them, but you basically toss in your old prints, your failed prints, your supports, all that other stuff. You toss that in and maybe a little bit of new material, but it's mostly recycled material. And what spits out is recycled filament.
Oh.
So there is also open source versions of it that are cheaper. You can take water bottles and do the same thing, for example, or pop bottles, however you fancy it. And it can do the same thing. I do know that there are some companies that do sell recycled filament just in general. And there are some companies that sell filament on plastic reels and other companies that sell it on cardboard reels. So they're trying. It's not there yet, but they are trying. So just include that. Should probably increase that a bit.
And I should say that I find in Tinkercad I am continually I work very fast with drag and drop, and then I use then I enter in numbers to do fine tuning, and I'm constantly messing with that snap grid to fine tune things because I work in very small scales. So you can move very fast in Tinkercad. You just develop a habit of mind. I suppose that's the case with any kind of.
So I think our previous speaker who did 2 sessions, Brent, was talking about just how the idea is to get you to learn the new software rather than the software itself. So that's kind of the case with this. Autodesk views Tinkercad as the, I think I mentioned this before as well, Autodesk views Tinkercad as the gateway to getting into AutoCAD and Fusion 360. So once you've got Tinkercad down, it's really easy to go to those 2 programs.
And in my experience, it then becomes it's the gateway. It could be the gateway to open source software too. I mean, you may not fulfill Autodesk's original intention because a lot of some of the core concepts that you're working with here are simpler versions of what you can do with Blender, for instance.
Just turn this into a hole really quick, and then...
And that's a crucial feature right there. A lot of what you do in Tinkercad is carve shapes using anti-shapes or voids in the same shape, shape set.
Right. Basically, any shape that you have over here on the right, you can turn into a hole. For example, this sphere right here. And that's, as Mark was saying, it's kind of like taking a lump of clay and then molding it using voids and solids. But just after like a few minutes here, I've got a pretty, it's not a great looking table, but it is a table. So maybe a little bit too short, maybe a side table that you can put a tent, an umbrella through, but there we go. So I was talking about that slicer earlier as well. We are using the Prusa Slicer with our Prusa printers because it just works pretty well together. But there's a bunch of other free slicer software out there, including but not limited to, oh gosh, I was just thinking about it, the Cura Slicer, Ultimaker Cura, which is what a lot of slicers are actually based on, is Ultimaker Cura. So the general idea behind a slicer is, like I said, you translate your 3D object into something that the 3D printer can print. For the most part, your tools are going to be the exact same in every single slicer, so I'm just going to import really quick that one. But so normally when you export an STL or something, that's not necessarily this finished product, but you don't really want to be touching it too much after that. But in your slicer, you can change like the size. I'll grab one of these so that it does it correctly, or proportionally. You can change the size of it so that it's bigger on the build plate, which the Prusa Slicer shows you a pretty decent looking version of the build plate, which is what the 3D object prints on. In some cases, you just get a simple work plane like you saw in Tinkercad. In other cases, you get even more details out of the slicer than what you even have in Prusa. You can rotate the object. Sometimes you might want to rotate it because it might make it sturdier depending on what you are looking for, or it can print a little bit faster depending on how things line up. I won't go through these other tools. For most slicers, you do have some basic print settings that you can just select. For example, there's a bunch of presets here. I've got a couple of my own here, but we'll go with the 0.255 millimeter draft. Supports are useful because obviously, for example, this thing right here, we do have a couple of, there we go. We do have a couple of things that if the printer, the Fdm printer, decided to start printing, it would be printing in open air, which can cause sagging, or in some cases just a completely failed print. So the supports prevent that from happening by building some supports that hold up that part while it's printing. Infill, for the most part, these 3D objects print hollow. Except I think for resin printers you can do it, but it's a little bit more difficult. They print hollow, so sometimes you need infill to strengthen the print. You can do other things to strengthen the print, like make the walls slightly bigger, but the infill kind of helps with that, and also helps with the top layers as well when you need to cover up the infill. I'm going to click on Slice Now. And right here we have a representation of what our finished product will look like. The supports are not completely correct, but I'm not going to worry about that. For the most part, most slicers will tell you roughly the amount of time. I've learned that this is not completely correct, but it is pretty close. The amount of time that it will take to print the object. Prusa does a really great job of showing you like what exactly is taking time and how much you're going to be using, of how much filament you're going to be using as you are printing each part, which is kind of cool. Most slicers also have these little widgets here, which show you basically how it's going to print. which is kind of cool if you're trying to demo off a object that you are doing. And then the final thing is you just export it to G-code right here, and you send it to the 3D printer, and then you get going. I'm going to switch to the dock cam really quick. Yeah, you can't see a whole heck of a lot going on right now, but what we are printing right now is a little tree frog, which I've got a finished version of it right here. So, yeah. Yeah. So, any other questions for me? Mm-hmm.
This is, I guess, kind of a, I suppose, regulatory question, but is there like a central repository for folks who do 3D printing where they can see any like limitations on what they can print or cannot print in their jurisdiction or what have you? Or do any regulations like that exist?
Just because of the way 3D printing is, at least in my experience, I'm sure someone else can speak about it a little bit more. But there really aren't regulations. I'm going to broach the subject, and it might be a little bit hard, but for example, ghost guns, 3D printed guns that don't have a serial number, there's not really any regulations for or against those, unless it's state by state, which I'm not necessarily keeping up with, but I really should. We're not going to do it, obviously, because we're at a college, and that would just be bad, just in general. But there really aren't any regulations that I'm aware of that prevent people from printing certain items over other items. Especially because a lot of 3D printers, it's their personal printer. It's not like they're using it for a company. I did see someone, yep.
At what point do you give up on the slicer and just design and supports yourself in your original design? Is there a trade-off point that you found when you're doing this, where you're like, for the sake of trying to get the supports in automatically, and I'm just going to build my cobweb around?
Yeah, there have been a few times. A lot of the times, supports leave trace material when you try to take it off. And honestly, a lot of supports are just very difficult to take off in general. So sometimes for things that are very, the program will design the supports for you, and sometimes it will put supports where there really shouldn't be supports. I try to look for those because, number one, it lessens the amount of filament being used and also lessens the amount of time taken to print the object. But for the most part, I just let it do its thing. I'm sure it's someone more experienced than me can definitely go in and say, yeah, I need supports here, here, and here, and that'll be it. I'm not that experienced yet, but I hope that answers at least somewhat. All right. Any other questions? Or cool. All right. I'm going to hand it over to Mark then.
My name is Mark Gallimore. I'm the director for the Center for Online Learning and Innovation. I do not have IT degrees. My degrees are in American history and history of technology. And so, I mean, just sort of following on a theme that Brent touched upon, all of this is accessible to folks with a wide variety of different backgrounds who are interested in creating, which is the sort of ethic of our office. I think we're going to go with...
Just hit laptop.
Laptop.
Yep.
So, just to follow up on what Tyler was saying, I made these drawings of a 1930s, 40s drill press. As if 3D printing wasn't a nerdy enough hobby, I build models of World War II stuff. So that's like severely nerdy. But the problem, of course, is that if there isn't a kit available for me to buy, well, how am I going to get stuff like if I want machine tools, for example? Well, 3D printing allowed me to do that. That model, by the way, is printed, painted, and is up here. And it's tiny. It's 1/35 scale. Because the drawing, I could scale it up to 1/12 scale in an instant. And I could print it at that scale if I wanted to. And so there's, I got into this as a hobbyist. and really unrelated to my job. Before I go any further, I'm going to say some things about resin printing, specifically it's sort of the counterpart to 3D printing. And this is a pretty typical consumer resin printer, an Elegoo Mars 2, it's mine. There's resin in this bottle. I want to address these questions that have come up. What is the moral and ethical implications of this? Okay, so environment, firearms. I will say, personally, my own ethic is that if I decide, and this would probably happen before there's laws or regulations that would limit my ability to 3D print, if I decide that this is morally problematic, I will stop. I will not insist on my right as a consumer to make stuff if this stuff turns toxic socially or environmentally. Guns is one issue, although I think the conversation we're having in the United States is about how easy it is to get guns of traditional manufacture. Maybe 3D printing is not yet, anyway. I'm not sure you have to resort to a 3D printer. It seems pretty easy to get guns, including those of a 50-year-old design, for example. Not naming names. The environmental one concerns me as a more immediate concern of this stuff. This resin, this photopolymer resin, is not friendly to organics like you, me, and my dog, and my daughter, okay? A few minutes of skin contact can cause skin irritation. There may be long-term health effects when it gets through your skin. You do not want it in your eye. It can cause eye damage. So you have to take precautions when using it. It should never, ever, ever enter the environment. If you're going to start 3D printing after you walk out of here, I beg you, please do all you can to be responsible with this resin in its liquid state, because if we're not responsible and we create an environment and a public health crisis, then none of us can do this. And I'm afraid, I don't want a situation. Look, Hooker Chemical, Love Canal, that history is just down the road. Let's not create a consumer movement environmental crisis. So, for example, I try very, very hard to make sure every resin that leaves my workbench in one way or another has been hardened into the much more benign, hard state, where there's even food-grade versions of it, okay? And I'll touch upon that a little bit. Real quick, the way this technology works, this stuff comes in a liquid bottle. You take a step to harden it using ultraviolet light. That's how the printer works. I have a box here, a cheap box I bought on Amazon where it's for nail polish. It hardens nail polish with ultraviolet light. It also hardens parts I print in my printer, finishes the curing process, and then I use water and isopropyl alcohol. As part of the curing process, I need to remove liquid resin dripping off the part after the printer's printed. Okay, and I'm using a water washable version of the resin. You can get other resins that require more potent cleaning agents like high strength isopropyl alcohol or a lot. It's part of the arcana of 3D printing, all the different chemicals that work better, work best. Whole lot of real estate on Reddit about that topic. So, to demonstrate how a resin 3D printer works, got the top off mine, there's a vat, there's a tub. The liquid resin goes in it, the bottom of it is clear, it's clear plastic. Afterwards you can come up and take a look. Here's one of these tubs with a clear plastic bottom. Underneath it is an LED screen quite similar to what's in your phone. It may be specialized, monochromatic, in order to flash silhouettes of UV shapes, 2D shapes, which are the various layers of the print as it develops in 3 dimensions. And so, and I've got my little diagram here. I think my mouse may have, oh, well, I should have asked it nicely. This build plate is on an elevator. It comes down into the resin vat, goes into the liquid resin. There's a very, very thin space between it and the plastic, clear plastic bottom of the vat. The screen underneath flashes a shape. and it creates a layer, and it might be 50 microns in thickness. It's adjustable. And then rinse, repeat. The build plate comes up, the screen flashes another silhouette. Let's see it, say it's starting 2 columns. Now, one obvious difference between that and this FDM printer is the whole thing's happening upside down. As it's coming out of the resin vat, the 3D piece of resin is taking shape. Ideally, the UV light is coming from the screen within the printer, is hardening it just enough so that it forms a nice, crisp 3D object. Again, there'll be some post-processing involved with UV light as well to cure that up to make sure it's fully hard after you get it out of the printer. But even before that, let's say this print is done, you will be faced with the fact that the hard resin or semi-hard resin, mostly hard resin, has liquid resin on it from the vat in the printer. This is the biggest problem with resin printing. I'll tell you up front. If you walk away today and go, this isn't for me, this is probably why. Once I remove this part from the build plate, I'm going to have to clean this part, clean off the liquid live resin, that's got monomers in it, that's got photoinitiators, that's got all kinds of chemicals. So then I can finish up UV curing this part, and then it's done, and then it's benign. You can handle it, and there's examples of them up here you can come up and look at. I'm still using a really crude system of this sort of nail polish hardening UV lamp, and I've got little pieces here. These are actually 1/35 scale building gutters, 1940s, gutters and downspout type of thing, which I drew in Tinkercad. And you can see that, like what Tyler was talking about in the FDM printer, I need to have supports to suspend this thing upside down in space as it's printing, and you have to watch out for circumstances where the part will, for a variety of geometric reasons, not be supported and will fall apart. The first thing my printer does is always print a sled against the build plate so that it has a firm purchase so the part doesn't fall into the resin before it's done, doesn't fall back into the liquid resin vat. And so I have to clip those off and clean up the parts. And I get all these parts, which I could not necessarily buy commercially. A hydraulic jack for a car, jack stands, architectural details, and a 1940s drill press. How did I learn about a 1940s drill press? Type 1940s or 1930s drill press into Google, and you get ads from Popular Mechanics magazine where they were trying to sell drill presses. So all I did was went shopping for a drill press in 1935. And that got me what I needed. And I went into Tinkercad, and I said, how can I use Tinkercad's tools to replicate these various shapes, tackle one shape at a time? Okay, I cheated. I used a bit of brass rod from a hobby shop for the post rather than 3D, because it was faster. Which is also another thing. Don't 3D print stuff you could get easily. Which is also, you get a 3D printer and you're like, I got to 3D print my life. Well, it may not be worth it. You really want bespoke objects. And this exists alongside an analog, very, very much analog hobby. So these are from kits, the Canadian Soldier and the Jeep. This is XPS foam you buy at Home Depot. You just carve it with a pencil and then you paint it. So it's this mix of very traditional art, very traditional craft, and then this new digital technology. One is certainly not replacing another. They complement one another. But this is the issue. Safety. This is a little dramatic. I deliberately kind of made the picture dramatic. Scared straight. I don't actually wear a respirator because in this photograph, just right here, there's a window, and I open it, I put a box fan in it, and I'm not smelling resin fumes. So I don't feel that I'm in an unsafe atmospheric condition when I'm 3D printing. Pro tip, keep the top on the printer though. When you have that vat exposed to the atmosphere, that's where the fumes really start to build up. So get your parts out, close the printer, and I find that it's not too bad. If you are working in a space, like for example, we're going to probably bring 1 or 2 of these types of printers to the campus, we will then probably have a forced air hood. And we may say to students, listen, you ought to wear a respirator anyway. It's an institutional environment, as well as maybe we'll do more rigorous printing, whereas I'm a hobbyist. I may do a couple of prints on a Saturday and that's it. I do always wear nitrile gloves. Vinyl and latex, I think, have problems where the resin, if it gets on them, it can get through them. It can break them down, so stick with nitrile gloves. And yes, you absolutely need to wear them. You do not want the stuff on your skin. Eye protection, absolutely wear that. Why not? It's super cheap. I wear the same ones when I'm cutting my weeds. It's just fine. And I wear a smock just to protect the rest of me. The workspace I work on, I have silicone mats laid down. You can buy them cheaply at a variety of places, slap mats. That'll stop resin from, especially it's got a little lip on it, so even if you had a major spill, it's contained, and you can get it cleaned up without too much danger, without too much problems. And so I do this in my home. I don't think I'm doing something that's extraordinarily dangerous. You can get the MSDS sheets for this resin. Does anybody bother getting the MSDS sheets for chlorine bleach you use in your home? I'm not suggesting you should, but my point is, in the scale, if you're safe, if you follow procedures, you should be all right if you elect to do this. And in fact, that's kind of leads me to sort of another tip. Before you buy one of these things, read about the process people use to print with them. And even like me, like I typed into like Evernote, okay, here's how I would do this. Begin with the end in mind and work back. What are all the steps I need to take so that I make sure I'm safe and I don't get into a situation where like I've got wet resin on gloves and now I need to open a garbage can that should not have a lid on it because I need to put things in it or something like that. Make a plan, lay out your tools like a surgeon, and then you'll just methodically work through the printing process and you'll be absolutely fine. That's one piece of advice. Another piece of advice is when starting out, like for instance, I have an Elegoo Mars 2 printer. But if you have an Anycubic printer, that's fine too, whatever the brand. I recommend, first of all, read all the instructions you can find from the manufacturer. I also bought Elegoo resin to start with, just because I figured chances are good the advice the company gives for its resin and its own printer, there's probably a greater likelihood of compatibility or avoiding some type of quirky issue, and then follow the instructions for the resin. You go to their website, you find exposure instructions, which list, okay, so how long should the UV light on your printer flash into the liquid resin to achieve optimal hardness? The 3D printing fans, they tweak all that. You know, those with a lot of experience will go in and see if they can lower that exposure number, for instance, and they may get better results. Don't do that starting out. Just try to get some successful prints. Build your confidence, build your experience. I learned that from an analog hobby, airbrushing. If you're going to airbrush paint, follow the manufacturer's instructions. Yes, buy the manufacturer's thinner, because that way you're operating as close as possible to what they say, this is how this should work. Then you can start tweaking and experimenting, adding Liquitex Flow Aid, adding some other chemical, something like that. Sometimes I'll go to Reddit and I see people are like, well, I just bought my brand new Resin 3D printer and I followed Master Ninja 3D printer here. He uses Soraya resin and then he tweaks this and he tweaks that and it didn't work for me. Well, because maybe she or he lives in Utah and they have a very different climate, you know, a humidity state and very different circumstances. So they may get different results. Maybe there could be all kinds of different reasons why you're getting different results. Just try to follow the manufacturer's instructions to start out. Then you can, as you acquire experience. Otherwise, because you want to get you want to pretty quickly get some successful prints. You'll get enormous satisfaction when you do, and you want that charge so that you'll keep going. And just to show you a variation on, Tyler mentioned the Prusa slicer. This is another common slicer that's used across 3D printing and resin, a Chichu box, and it does a lot of the same features. I can very, very quickly run down the layers of this print. You can see that I have supports in place to support it. Of course, it would be upside down on the printer. This actually, I like this print because it shows the potential for this stuff to go beyond, you know, my little hobby tinkering. So this is a replica of a dog's jawbone. And a veterinary school does not need to use real bones for students on a day-to-day basis. Even if they could get dogs' jawbones that were donated from dogs that passed away, you know, you're gonna have a problem where you've got 12 students. I want them all working with an identical model because different dogs are different and may have different teeth patterns. And so I want to make sure we're all talking about the same feature. Besides, I can hand this to a student. I can make a bunch of these. Yeah, go ahead and, well, okay, this is, I need to scale it down some. I would, without even getting into that, I'll just say you're looking at a couple of cents worth of resin. I mean, the bottle is like 30 or 40 bucks a bottle, but when you actually print, it's very little money. And considering what it costs us, I mean, when I look at the printing budget for a university on paper, it's gross. The amount of money we spend on print and toner, which is why I make war on paper in my day job. But I could print 12 of these, one for each student, and tell them, you can mark this up with a Sharpie, it's yours. You know, so we all have, you have 3D models to help you study for the exam or to help you understand the anatomy of a canine, of a dog, you know, that are yours. It's a printout, to use a traditional term. And you can see I've got multiple parts on this. I've got this dog jawbone, and then I got pieces from my little drill press. Resin printing, by and large, FDM printing, the bigger the object, the slower, the longer it's going to take to print. Resin printing, that's true in one dimension. But because an entire layer is flashed all at once, instead of this thing drawing a layer over time, generally one dimension, slight exceptions, one dimension determines how long it will take to print something. And for example, with my water washable resin and my Elegoo Mars tube, it's like, I don't know, maybe a centimeter an hour. So I set up a big long print to print overnight, and then come back in the morning. I am concerned about the environmental issues here, so I'll just say, lastly, again, if you get into this, please, the liquid resin you can put back in the bottle. When you printed something, you can put the remaining resin back using a paint strainer. And please do not allow do not pour it down the drain. But don't do something else with it, like just throw it in the trash. What I do is I take the trash that I generate, like paper products and things like that, and I hit them with UV light, and I harden that resin that's even going into the trash. And as for when I break away all these pieces, I actually save those and use them as filler in my hobby. So they go. I just put them in a big old bin, and then I use them whenever I need some sort of fill. For something. So we have a printer printing here. We have some examples over here. Please come up and take a look, and we'll stick around for a few minutes if anybody's got any questions. I think we're up on the lunch hour though, so, but absolutely we'll stick around and answer any questions you may have.
Thank you.